Very good morning to all. In this session, we're going to discuss about pipelining. Why we are using pipelining? Actually, to improve the performance of CPU, we have only two options. One to improve the hardware by introducing the faster circuit. Another one is arrange the order such that more than one computer can be performed at same time. Only two possibilities there. In case first case, to improve the hardware by introducing a faster circuits, which leads to high cost. So that most of them choose for second one. That means arranging the order hardware such that more than one operation can be performed at the same time. So that pipelining process is came here. That means arranging hardware. This pipelining techniques is came. The pipelining is a process of arrangement of hardware element of CPU such that its overall performance can be increased. In this diagram, which describes about uh, non-pipelined architecture. In this case, we have three instructions: instruction one, instruction two, and instruction three. Now, each instruction will be executed one after another. First instruction one is executed. After that, instruction two is executed. After that, only instruction three is executed. Uh, so that what will happen? Time consuming will be more. The performance of the processor is very less in case of non-pipelined architecture. Let me discuss how the performance is improved in pipelined architectures. In pipelining, we have four stages. One is fetch, decode, execute, and store. In fetch stage, which is used to read the instruction from the memory. Decode, which is to decode the opcode and fetch the some operands if necessary. And third is execute to perform the operation specified by the instructions. And fourth one is store, which is to store the result in the corresponding destinations. It's a phase state diagram which shows that we already seen one diagram, which is the instruction one, instruction two, instruction three will be executed one after another, which is a non-pipelined architecture. This diagram which indicates that instructions are there. Instruction one, instruction two, and instruction three is there, as well as this indicates the number of stages and this indicates the cycles. Initially, instruction one will be fetched during the clock cycle one. As we have seen, four stages: fetch, decode, execute, and store. Initial stage is fetch, that will be fetched in the instruction one. And second clock cycle, this instruction one will move to next stage, that is a decode stage. During the second clock cycle, simultaneously, instruction two is fetched. And during clock cycle three, this instruction moves to execute a phase. Simultaneously, instruction two will be moved to decode phase, and the instruction three is fetched during clock cycle three. That means three in clock cycle three, three instructions are handled simultaneously. Then in clock cycle four, what will happen? This will move after performing the execution process. That means specified operations. It will be moved to next phase. That means store writing the result. In fourth cycle, this I2 move to the execution state and I3 will move for decode state. Simultaneously, this operation is performed till the I3 is completed. When we calculating the clock cycles in this three instruction means we only require only 6 clock cycles to complete this three instruction, as well as this are executed simultaneously, not one after another. Then in case of non-pipelined architecture, if it take the same instructions, what's the time it take means it take a clock cycle time as a 2 clock cycles. Same three instruction, time taken to execute one instruction, that means 4 clock cycles to execute one instruction. So totally 2 clock cycles are needed. So this clearly indicates that pipeline execution of instruction is more efficient than non-pipeline executions. This is the basic operations of pipeline architectures. Thank you.